So what are we doing here? We got motors and hub plates. These hub plates, grab one. And these motors. This is our 15,000 inch pound motor. So this is several years. So these are the things we're going to mount. Oh man, can we do it? So this is tricky now, so we're going to have to do some welding. So this thing goes on top. It's got a keyway. It's got a keyway and a cast steel nut. That nut you take off, and we need a cotter pin to go. There's actually a hole at the top there. You see, there's a hole. So you'll put a pin through that. But this thing goes on top. And then this is standard way to do it. You got a key and then keyways. But how do you do that in terms of machining? You have to have more tools. So we're trying to design the tractor like no tools. But torch welder and wrenches.
What is it that we need to put?
We're getting there. So now we're going to put a plate on top of this, a plate that will hold this sprocket. This was actually like a direct wheel drive motor application somewhere. This is from Surplus Center. But what are we going to do instead?
There's that. Oh, here's the.
Pardon? Yeah, that's a hydraulic motor.
Soldier. And this we're going to actually make from scratch.
So how hard is it to make a hydraulic motor?
Only a good lathe. How hard is to
Can do it as a spare
A
time.
hydraulic motor, just like going like we have absolutely nothing in how
This
It's
is
precise.
so much
It's
energy.
to a fraction of a thousandth, like
That's what I
half a thousandth or so.
CNC.
And how do you do that? The process is you can mill it rough first, and then you do precision grind.
drill grind.
Yeah. And so grinding, because it's fast spinning abrasive, puts very little force on what you're working on, and therefore you get very precise tolerances like that. Now, the good news is that tools like that do exist. There's a thing called like an open source air bearing lathe. On the internet, check the wiki. Well, there are ways to make tools to do these, and these are part of the GVCS. So we are going to be making
The
our own.
hydraulic motor is.
Yeah, hydraulic motor is, it's got to be, it's pretty essential to what we do.
Yeah.
So, a metal plate, I don't have any of these plates. So we take a piece of steel, a steel plate. I'm just going to take this plate since I have it right here, but it's going to be a blank plate, just a flat plate. We're going to drill out the hole pattern. So you got to, how do you mark that out? How would you mark it out? I guess.
Put tape on it or something, and then put it on and tap it.
I'd probably
Alright.
take a piece of
You can
paper
mark
and
it.
put it through the holes, and there's your template right there to put
I'd
on.
put some Sharpie on the ends of on the screws and then set it on top. and
Yeah,
pull it off.
it's
I think
a bit rough edge.
Tape
though,
would probably be more
or
precise to
paper.
get the stamp. Yeah.
Piece of paper or
Cardboard.
cardboard. If you stamp cardboard, you'll get a pretty explicit pattern. Like, put a piece of flat cardboard, just tap it, and
If you put the
We'll do
tape
it.
on that, when you tap it, then it's actually in the place you want it.
Yeah.
yeah, do that. But measure it so that at the end of the day, your metric is your plate going to fit on top.
Yeah.
If it doesn't, what you'll do is take a drill and drill out maybe one of the holes that don't fit or whatever. But that has to be pretty precise. You want it to be as tight as possible. So if this is a 1/2 inch, you want to drill 1/2 inch holes, not like bigger. No tolerance. Just it has to be pretty precise. Otherwise,
Just vibration and
it'll wear out over time.
And
So
that plate is then getting or
no, that plate we drilled bolt holes and we're going to put nuts on it.
oh
Those
yeah,
are
that sprocket comes
those
out.
are
does this
1/2 inch.
sprocket get welded to the plate?
Sprocket?
Top of the plate,
Yes.
or?
So how do we do that? If this is So that's going to be spinning. That shaft is going to be, everything here is going to be spinning together. So you can bottom it out against the shaft, but you're going to have to extend it a little to the, first of all, above these. So if you put the plate on, it's going to be like there. So now we're going to need to have a standoff for this so that the fat chain, which you have here, what goes on it is this chain.
How do you extend the shaft? That's what I'm wondering.
I guess we need to weld something out to.
But welding on top of that guy,
Yeah.
doesn't sound.
I guess we're not extending the shaft. That's the.
We're not.
I think are we gonna terminate in that sprocket?
As long as the sprocket comes above
So this is
these
going to be our,
and the chain fits.
our motor table here. That's going to be drilling. That's going to be tubes. But so we can lay this out here. But this is what we got. This is 80 weight chain.
And this is to
Pretty
do
heavy.
it, the
This is-
like
this is the-
flexible connect, like
Drive
connection.
to the shaft.
Yeah.
This one's the double coupler that we used over there. We're not using that. We're using single chain. So this is it. You got a chain breaker tool.
How does this single work? I thought that it needs that.
One,
This
one
is
on
to
each
here.
side.
Our shaft compared to this, this is our motor mounted. This is
the
our
drive.
shaft
This
here.
is not a coupler, or not coupling shaft together.
Not doing this. We're doing this.
Gotcha. Yeah, yeah.
So we're gonna take one of these, and we're gonna drive it with this small sprocket.
Yeah. That
How much advantage do we have? 3x. 10, 30. 80 by 30. This one says 80 by 10. 3x exactly. So that's cool. How do we do it? So we'll put the plate, wherever the plate ends up sitting, we're gonna stand this off using something like a coupler, like a,
Ah, now I got it. I see.
use like,
Okay.
But this is gonna spin with it?
Yeah, this will be
It can't.
bolted.
That's what I don't get.
This is not gonna spin.
Yeah.
Only the.
No, it can't be. That whole piece.
This whole
This
thing
is gonna
spins,
spin.
Yeah, that whole.
but that whole thing,
That whole
This,
thing.
this entire thing.
yeah,
Ah, okay. See,
because that's
This is
for a
what's spinning.
direct drive to bolt
No,
the
this
wheel
is fixed.
onto.
This
Right,
is
right,
fixed.
right,
no, this is not fixed. That's otherwise.
this is
spins.
rotating.
Yeah.
See, this is valuable information.
So this is
What's
like
spinning
a-
and what's
This is a spacer.
Big.
stationary.
It's important. Yeah.
We'll find out soon.
Well, it's the
Okay.
coupler. You're coupling this. You're putting nuts on it to hold it.
So the sprocket gets welded onto the
Yeah.
plate.
So we have a little standoff, and that's probably what we're going to want to use, something like this. So that's as wide as possible while allowing you to drive the train.
How do
Fall
you
on
set
top of
that
that, too.
exactly in the
Yeah.
middle?
So how do you do that? There's a lathe there, back there, so we're going to have to bust it out. We don't even need to have power. You need to spin the lathe even by hand to note. When you even spin it by
Just
hand,
visually, you'll see.
visually you'll see.
Yeah.
And there's a tool called a dial indicator that you can use to help. We have that, and you can see like it's a pin that hits it in,
Yeah.
and then if it's off center, it'll make the dial move.
Yeah.
We'll see that. But this is probably, if you take a look at this chain. And this is actually heavy chain, so the side links are actually a little thinner, and you can see that than that. So I got heavy chain, which breaks less easily. So this is good for about 4,000 pounds of pull, which actually, this is like 3 inches or so diameter. So radius here is only like 1.5. It's like 3 inches across. We're only like 1.5 radius. So this chain's actually a little weak for this application. We have the torque on 1.5 inches is about 10,000 pounds. The braking strength of this is like to 20 or 30,000, but its working strength is much lower than that. So it will work, but probably in a lifetime version, we're gonna like double up or go to 100 chain. This is the first time we're doing this. The double one, you could do a double, weld 2 of these and a double, you solved your problem. So actually, when we do that, we might actually think about it so we can weld a second one when we're ready for it. So how tall is this going to be off the, well, it's going to have to be above the lugs. So it's going to have to clear, like wherever your plate ends up, plate's gonna end up like right close to the lugs. Well, no, actually you don't wanna do that. What you wanna do is you need to drill out that hole so that all the surface is on, that you need a solid connection like that. So it's gonna end up like right there. You're gonna have your lug bolts, so you're gonna have to have a standoff about that long, so we'll cut.
You have to have enough space above
clear the
for
chain.
the lugs to come.
So you're gonna need enough to, so that's like a 1/4 inch or so, how much we got there.
Yeah, no.
More like close to half,
One
like
and a
3/8. 3/8 inch about, to clear. So wherever you got your nuts or whatever, the lugs,
Yeah,
you're gonna have to
It's
have
gotta
that
have enough
spacing.
to not,
Yeah.
Should do like 1/2 inch space, clears it by like 1/8 or whatever. So this plate, the other consideration on it is, you gotta get the nuts on.
yeah, that's what I'm trying, that's
So
what I'm
you-
aiming.
If we find that there's an issue with that, no, I think we can get the nuts on, but if you couldn't, you'd have to stand it off
You've gotta
even
get
more
the
so you can
tool
put the
over
nuts
your
in.
nuts too. I suppose if it's an open end, then you're fine, but
Yep.
like, if you're actually putting a
But I
spanner
thought
on,
we
you're
were
gonna
gonna
be,
stand it on top of this.
Yes,
Yeah, but not that length, I guess.
No, of course.
not that length.
Yeah.
As short as possible,
something-
I understand.
As wide as possible, because you want that connection there to be really strong. But not that wide that you're actually not
Or
being
messing
able
with the
to.
chain.
you don't wanna touch the chain.
So
Right.
here, okay, so in reality we have this. That fits in, but you need a weld. So you really kinda, if you're gonna do a solid weld, you really gotta be within this kind of a, more like
It's actually
this.
pretty tight, huh?
Probably need like more like this where you can get a good weld in there, cause you still need that weld there. This is gonna be welded on.
It's good to have a gap, you mean?
It's not good to have a gap, but we want to be.
Something that fits inside.
It'd be nice
Get
if
a
it
Enough.
shorter weld.
fits perfectly inside, basically, and then just weld it on, right?
We have tape.
Yeah,
That would
you have
be
tape
kinda
too.
ideal.
You could do tape.
And then just burn it off
But-
by welding.
Spin it on a lathe so that you see whether it's wobbly or not. So just, you can do it by hand. Just spin the
mean-
chuck by hand.
You can lay something down, right? So it fits into
You
it
can.
too. Because that
Yeah.
will keep it very straight as well. Then you have the lathe constraints.
Yeah,
I don't know
Yeah.
how to work a lathe, but yeah.
yeah.
Yeah, which we should
It's a
probably.
big drill, basically.
I don't really.
Just
I mean,
spin
by
it by
hand
if you spin it by hand, you'll see it. Like, how much tolerance do we have here to mess things up? Well, because it's a flexible connection. Like, first of all, you look at how much space does this thing wobble in there? A little bit, very little, not a lot at all. But like, if this angle is off a little bit, well. I mean, by eyesight, you want to be as close as possible because you got a flexible connection with chain, so you can take some, but you want to be pretty close.
But
So I
that
think
does
just
over time equal, like, fatigue.
yeah, it's wear over time. So yeah, you want it straight, really straight.
So my question is, for the long term, how do we simplify this particular step? Is it getting a pump that has a different shaft on it, or a different attachment, or, you know?
To simplify this step, you would make a motor like this that has.
Why would you want to simplify things, man?
It would just be nice if the shaft just went right into the sprocket.
Man, you're just talking crazy. We afford that for us to get to it.
I mean, if we had the tool that you could drill that friction fit cone, boom, straight in, and then you're done.
Yeah, this is
That would be
this. You're right. You're exactly right. What we're doing here is taking surplus materials and trying to make them fit. No, that's not what you do in real life when you actually do this right. You put some shaft like this fat or the square that we already use, and that's it. Put something that already can be coupled to directly, not through keyways, but through geometry, like hex shaft, spline shaft, or whatever.
So is this pattern kind of unusual, this screw pattern, or is that industry standard?
That's a regular wheel
I don't know.
pattern right there.
It's probably going to be somewhat regular, but when you say regular, there's like 100 different standards.
Okay.
So
Okay.
When you said drill this out before, did you mean the plate or this
Plate.
extra shaft? Yeah.
plate. This goes on, and then you put that cotter pin. The cotter pin looks like.
Wait a minute, are we designing in, if that ever needs to be taken off, you have to be able to get that cotter pin out.
Yeah, which means you unscrew these and then lift the plate.
Okay, yeah, okay. Yeah, alright.
So what exactly is the function of that? Like, why don't we just like
Yeah.
connect directly to the drive shaft? Is that so that they're not welding onto it and then can't remove it after the fact? Like, what do we need this for?
You want to
that's
weld to
spinning.
the shaft?
I guess that's the question. Is that the alternative?
It'll break. It'll weaken it. When you weld, you get crystallization. It'll weaken the shaft and break.
And that is also then heating up the motor, right?
You can submerge it in water to keep
Okay,
it from.
while you're,
So then you freeze one of these. Where is that hole?
and one wants to like tighten that as much as possible before putting that in, correct?
Yeah, you gotta tighten. So maybe it's not tight enough yet. So, but then you're gonna put in one of these.
It's a pin.
Yeah. So get it in from that side is interference. So here, get it in. We need a slightly smaller one. So one of these Castile nut is what it's
Isn't one
called.
side supposed to go above?
No, both sides, and then you
Just bend it.
both of them. Yeah, both go in, and then you bend it out too, so it doesn't come out.
So, crazy thought, what about taking something like this, threading out the middle so you can put it right on the shaft, and then laving this down so you can put the sprocket right on it?
Well, we already have connection with these.
This is a solid connection. You need a solid connection like this. There's a tapered shaft here.
Too wobbly.
This is super precise tapered shaft. So
If we had a machine that we could do that tapered
Can't do that.
connection,
Oh, okay, alright,
this is too easy. This needs this kind of couplet. Only thing you could do is maybe like torch. See, I don't know what kind of steel that is. It may be maybe cast and not super weldable. So, but what you can consider is, okay, I'm just gonna weld directly to this, weld my sprocket directly to this, but we're gonna question that. Like, we know we can weld to this
Then
kind
you
of
can't
steel.
get-
This
right.
is, I don't know what this is.
yeah,
We yeah, man.
and then you can't get it on and off. if you-
We're talking extreme here. This is 15,000 pounds pushing right there.
Yes, that's different.
You need that to be right. And you have to think about impulse shocks, which can be 10 times that. So you're talking
quite a-
about the ability of this to handle about 150,000 pounds right there. You don't want to do anything but what's already on that. So all these, now this bolt pattern is further out, so those get less, and there's 5 of them, less force on it. But right here, ooh, there's some extreme force there.
Okay.
So you got to do that. So what do we do here? We're gonna figure out. We're gonna get probably we'll see if we have something a little thicker than this. This would actually work. This would work well. You just got to get it straight. So put it on a lathe and get it straight. And this is pretty precise stuff. So only people who know how to line things should do this.
Do we decide on the height of the extension?
No, because what we'll do is we'll start with a plate. We're gonna torch out a plate, put the
Okay.
plate on, and then work from there. You can also throw this into CAD. If we had a precise model of this, then you can actually work it out in CAD. That's where CAD would be useful. But we'll just do it in place since we don't have. And in the long term, we'll be making our motor. What I would do is I would, do the 3-inch shaft or some kind of a well, 3-inch we could actually weld the other stuff to it too. So I would just make motors with this kind of 3-inch, whatever this is. This is like 2.5. But bigger shafts, because that's the sensitive part. Bigger shafts make it easy to work with. So we'll do that. Let's see what we can do here is someone reasonably able to mark things. We can take those plates, cut them out, then put them on the torch, cut them out. Well, just torch the circle. So mark a plate, and then mark the bolt pattern and drill it with the mag drills. Using I think we do have one annular cutter. That's 1/2 inch, so we can use that. It's a small one. Annular cutter is, because it's annular, it's got a hole in the middle, it's easier to drill with that than a full drill bit, so that'll be the preferred way to do it. We have the 1/2 inch. So this, we have 1/2 inch, that's what I'll be looking at.
These are 1/2 inch bolts.
Yeah. So is that right? That looks about right.
It looks it's
about-
maybe a little big.
Yeah, I'm thinking the same thing. But, isn't
Can
it
take
marked?
calipers.
Isn't that kind of-
Yeah,
Have
it's
some
marked.
right
It says
here.
1/2 inch. Yeah, it's marked. It says 1/2 inch, and let's see if we see any different.
Mini calipers.
Exactly, 12.5.
Can you go?
Yeah, this is
don't
Now
move.
check
Don't
that.
move.
This is less than 1/2 inch.
Okay.
No, it's 1/2 inch.
There you go.
Let's see.
You're in digital pair.
Yeah, it's the same thing. Same thing. Yeah, it's 1/2 inch fine, but it's fine thread. Don't use regular nuts. These are fine thread. If we don't have them, we'll get some more. So don't try to force a nut on it. That won't go on. This is fine. Fine thread. There's fine thread and regular thread. This is fine because you want finer thread is stronger. You got more threads. So yeah, so we can do this one for the actual drilling, and
So you need to
so you
put
can
a,
take
a circular plate.
6
alright?
inch. Yeah. So what do you start with for stock? This is about 6 inches. You could easily start with 6 inch stock.
Do you have like a
We have
compass with points on prescribing that? Or?
Might be a compass in there.
Is an angular plate good enough, or you want to have
But
it
if you
round?
trace,
Yeah, although you'd end up with that.
well,
If you
I mean,
flip it upside down, kind of just put your
Yeah, I
pencil
guess.
along here.
yeah, compass. Yeah.
Compass would be better.
The outer part is not critical at all.
No.
The bolt pattern is critical.
Just don't know. It's a bit scary if you have a rectangular thing turning.
Right.
It's not very high
Let's me torch
RPM,
out,
so
so.
Okay.
should be good.
Low, very low. This is
Yeah.
one-
Okay. Okay. Yeah. Yeah.
This goes to 120 RPM. Slow. These are slow, high torque wheel motors. So that's second. So we got the frames, we got the reaming out the holes, and we've got plate making.
120 RPM
Now,
though is
what else?
pretty fast.
Third
Really,
step now?
for this.
If you
For,
see it
like, if
spinning,
you were
you
actually
don't
going
want-
that
Bearings, too,
fast.
that's the
You know, the
third, right?
bearings,
But how,
and we've got
like,
Power
horsepower?
Cube stuff.
It's
I
not
can
to do
maybe work with that
the
team
horse-
there.
that horsepower,
Now
it's
it
not
wants
the
the
pressure
Power
there,
Cube,
it's
we're gonna
the
take the,
actual speed that it-
take what we have, tank.
The engine's
gas
ready to
tank.
pull off.
Yeah,
Yeah.
we can,
This way, I think.
one side of the Power Cube is taking the, so the easy part is take the engine with the pump and mount it in our rebar structure. And let's talk about how do you make aligned rebar structures. What's an easy way to make a cubic, because we want to make a cubic thing. How do you do that? How do you make a cubic structure if you're going to weld it from rebar? What would be the procedure? I've done this, I know how to do this. Does anyone else know how to do this?
3D
You set the
printed.
square on, like, on, I mean, you use it.
Corner of the table.
Yeah,
We
corner
got
of the table
square.
or a nice square line on the floor.
Use the magnetic
Yeah.
things.
And get your first 90-degree angle, and then get your other. And make sure, do a 3/4 on 2 corners, so that you don't end up with a parallelogram. And
Before or after welding?
before, although it doesn't when you weld,
When you weld, you mess that up.
you get
So-
a move. So like, you said it slightly open, more open. I can't remember.
So tack it, take 4 pieces, use this corner, take 4 pieces, whatever size you need. So we decide, let's just decide on 2 by 2 feet. Do we have enough for 2 by 2 feet? No. We got enough for 2 by 18 inches. We said 18 or 20 inches. Maybe we start with 20 since we have exactly 60. Well, maybe just do the 18. as long as we verify that 18 fits our engine. So let's do 2 feet by 18. Then what? Let's make it 2 feet high. Well, no, we just get that. We'll get those dimensions off the engine. What's the height of the engine plus pump underneath it? It's got pump under. So, in terms of technique for welding, okay, so that you talked about one side square. Let's say we can make one side square. What do you do next?
Make 2 of those, and then
Hmm.
I
Back
don't know,
together.
clamp them to something. And
So, printed parts
I
might
don't-
work.
Yeah, you could, but that's the hard way because how do you hold something vertically? That's really hard. That's like you got to do that over and over again. So what I would suggest is what we do on a
Attaching
3D
it.
printer frames, which are like these frames. Oh, like this. Look at how we did this. So if you look at this, now tell me what you do.
6
Just
squares.
flat, yeah, flat squares.
Cut it
6
out of,
squares.
so
smaller
you're
pieces.
talking about doing it with rebar. So you're saying we'll end up with like 2 pieces
Double.
of rebar. Okay. Yeah,
Oh, okay.
that makes
You're
sense.
guaranteed a cube.
Yeah.
If you go vertical,
Yeah.
you can. You have a flat surface to work on. That's
Yeah.
your friend. So you can make 6 flat sides. You put them together, you got a perfect cube.
And it's
So that's
much
it.
stronger.
What's
too.
what's this dimension?
We're gonna measure exactly, but we said nominally 24 by 18.
And would that just not be nicer to just choose a cubic measurement so we're not actually making a rectangle?
Well, 2 feet time does not fit. It goes
Yeah.
to the very end. If you have a little bit off, which you may, it will not fit on the 6 feet. So a little under, which was 18.
And then
24.
the other height is going to be determined on the
We're gonna
motor
measure it.
itself. So
We're gonna measure what we got on a Power Cube Plus motor, which is already there in one piece. So we
Yeah.
have exactly that to work with.
okay.
So welding those rebar cubes will be a cool task. If we feel that they're not strong enough, but effectively you have a 1 by 1/2 side. That should be
That's
strong.
good.
I don't see any need to do like triangulation or whatever.
That's what you
I think it will be fine. So
Not
just
with
do
2
that
on
if we
each.
I think so.
if we find it's not needed, well, not sufficient. We do like a cross.
You know,
Do like triangle, like a square across. That will fix.
24 pieces of rebar.
We'll see.
even just some like
Yep.
corner braces in a few spots that don't block access to.
Yeah, you want to have. Well, so we're considering for the mother Power Cube, which I would also just do out of rebar too, because we're still prototyping on this one, and I think the rebar is actually a cool thing to do it like a very transparent structure. But on the mother Power Cube, we want to be ready for up to 3 fans, because we know that one of those fans that we have handles heat rejection for 27 horsepower. So we're going to prepare. So how do you do it? I would say there's 3 sides there, and there's 4th one right there. So let's say a fuel tank and gas tank high. So if they're on the same level, you never have problems priming either fuel or hydraulic fluid.
Could you possibly, like running in cold temperatures, run the risk of cooling it too much? Like would you want to be able to? Well, not that it would freeze it necessarily, but I don't know. Is there any? Just
Now once you started, upon startup, the
But
only
if like
thing.
it's a cold day and it's blasting all those fans instantly or something, and it's like below freezing or something, you might have trouble.
It's
I don't know.
after, it blasts it after it runs through the pump.
Okay.
So, no, I mean in practice, but you can have a thermostatically controlled system where the fans don't turn on until you get a certain temperature.
Yep.
Here it's not a smart system yet, so,
It probably doesn't need.
but that doesn't really matter. The biggest thing in the winter is if you've got that cool, very cool tank, what you need to do is, it's hard to start one of these engines in the winter sometimes, if it's like negative Fahrenheit. So what you do is you take the inlet and outlet, just bypass basically, do a short circuit, hydraulic short circuit, so you have very little fluid to pump, because that fluid over the entire circuit has a lot of resistance because it's just thick.
It gets
So then you
really
short
viscous.
circuit the two, start it, let it run for a minute or two, and then until you feel the tank like starting to get warm, and then you can crank it again, and then you'll push it through the entire system.
I guess you could like heat the tank up or
You
something.
can put a
You could do-
immersion heater in there.
Yeah, or like,
These are typical gasoline engines too. Taking a standard automotive thermostat and dropping it in the system is relatively simple.
Very simple, yes. Just didn't do it yet.
I remember my
So,
friend with his Volkswagen would just put his Primus engine, camper stove under the bus and heat the engine block for about 2 minutes, and it would start right up and then like 20
Sure.
below.
just need heat, and they
camping
have,
That's great.
they also have like heater pads like we use on the printers. Those are used for heating
Yeah.
things.
Stick a bit off my 3D printer, you know.
Take your halogen heater off the 3D
Yeah.
printer. That's faster, actually, because you got direct radiant heat as opposed to thermal conduction. So, how many power cubes are we gonna make? 3 or 4? Yeah. So let's get frames for 4.
All rebar.
But start.
Not all the same size. Though,
But let's-
right?
Thing, yeah.
Or- 'cause we got the mother
Well, there's
and
the
then-
mother plus 4 babies.
Oh, 4.
And were we just talking about the mother dimensions, 24 by 18?
We're gonna, no, we're talking
That's
about
one of the
the engine
child.
slash, we know that engine slash pump combos are easy, we've got it all fixed. For the other part, we're gonna have to think about how do we mount 3 fans, 2 reservoirs, and filters on that, and plumbing, like, the constraint there is, say you got this, it would actually be quite convenient to put like 3 of these power cubes in the mother on top, but then we can't really take off the bottom ones. So maybe like if we put it behind, you want the path to suction be as close as possible. So you want to feed the babies with the hydraulic fluid in the shortest circuit possible, just, shortest. So it'll be in the middle, to 1, to the 2nd, to the 3rd. Gasoline, that's easy to handle, that's gas line, but the suction hose, that's like thick 1-inch tubing or 3/4-inch tubing. You want to run those things as short as possible, but elevate the tank so you never have any problems priming or like getting air.
If we could do a session on power cube design quickly at some point.
Yeah, we could do that.
Yeah.
Can do that for lunch.
We probably want to get the bandsaw running, right?
Yeah, Benso is gonna need. It's got a water reservoir back there. Grab some water from HabLab. That thing is probably half full. Make sure it's on full so that it's water cooled. We got to move that table out of there.
Yeah. And-
So
We could just cut rebar on.
no, not on that. Abrasive cutoff is super quick.
Okay.
That'll be like it's faster on the cutoff.
Okay. That thing doesn't just go.
That we will use for cutting slabs, which is a second of cut time. We built that, so just FYI. So
Yeah.
that was the one that took 6 months to build, and then we built another one in 2 days.
Yeah.
There's one next to it.
Yeah.
No, that was the first one. That's the first hole puncher. Now that hole puncher, so that's where this thing is kind of worn out here. Like I don't know exactly, but you can see how it got kind of reamed out. This has 120 tons on it, so it's got quite a bit of force here. If you wanted to revive this thing, we'd have to take this thing off and probably like. So this is like this punch going into this hole. It can work, but it's a little dangerous because it's misaligned. So you can actually still use this, but let's not use this. If it's